Welcome. In this video we will examine the Dunning-Kruger effect. The Dunning-Kruger effect states that people very often overestimate their knowledge or ability in a specific area, and that especially those who are very secure of their own abilities are very often indeed are not very able. Famous example, Donald Trump, who thinks that he himself is a very stable genius. So Dunning-Kruger is one of many cognitive biases that we need to be aware of science to avoid them. And one of the most famous books about cognitive biases is this Thinking Fast and Slow from the Nobel Prize winner for economics, Daniel Kahneman. So in our questionnaire we had these three questions about the population distribution, about the growth of a culture of bacteria, and this little riddle about the table tennis racket and the ball. And these are questions from Daniel Kahneman's book, and the first question is from Hans Rosling's ignorance test. So we assume that most people will get most of these questions wrong. We will now compare if those we had a question about how do you rate your general knowledge, and then we will compare if those who rated their general knowledge very high could answer also many of these questions correctly, or if the opposite is the case, that those who thought that they have a very high general knowledge could answer only few questions correctly. So we'll proceed in the following way. We will have a look at these variables, racket, bacteria and world population, and recode into new variables where we have a 1 for every correct answer and a 0 for every incorrect answer. Then we will add all the correct answers so that we have a new variable in the end with the number of correct answers for every participant. So then we will investigate the relation between the self-assessment of general knowledge and the number of correctly answered questions. And we will also calculate a Dunning-Kruger factor, which is the difference between the self-assessment of general knowledge and the number of correctly answered questions. And then we will see if we can confirm the Dunning-Kruger effect in our data. So let's start with the first step. We want to create some new variables. We have forgot to delete this one. For population distribution, bacteria and racket and ball, so that we have a 1 for the correct answer and a 0 for the wrong answer. First step is always I start sorting the data. So racket and ball, here I have crossed in that we have headings. Can confirm that. I have sorted now racket and ball, so let's start with that. So I create a new variable, racket ball 1 0, and for every false answer I want to have a 0, so 90 cents is obviously the wrong answer. I make a double click and use the autofill in function. Then I scroll down to €1.05, which is the correct answer. Here we have it. Here I enter a 1, again use the autofill in function, double click in the corner, and then I scroll down because I think we also have €1.10 and things like that, and that is obviously also the wrong answer. So here I have to insert a 0 again, autofill in function. And now I have a 1 for every correct answer and a 0 for every wrong answer. Let's continue with the second variable. We have to do that also for population distribution. So first step again, we sort the data. Now I take the quick sorting. I insert a new column. Heading is population distribution 01. And A was the correct answer. We have 4 billion people in Asia, so here we have a 1. Double click. And then I have to scroll down to B, and from here on the wrong answers, you have wrong answers and they get a 0. Okay, now you should do the same thing for the last variable, bacteria ball. First step is again sorting the data. Second step is inserting a new cells, a new column. Bacteria 01 is the heading. Now 11 days was the correct answer, so here we have a 1. And the rest of the answers were incorrect. So we can insert a 0. Okay, now we have recoded these 3 variables into 1s for correct and 0s for incorrect answers. Now we want to have the number of correct answers, and we call the variable CA for correct answers. And that is just an easy formula. When we insert a formula, we always need to start with equals. So now we want to have equals the first variable plus the second variable. Oh, here something is missing. Okay, I have put in the missing numbers here. So again, let's use the formula. We want to add all these variables, so plus, and here we want to have the sum. So we know that this participant had 2 questions right and 1 question wrong. So we want that for every participant, just a double click. We can also use the autofill-in function for the formulas. Let's make a double click here. Here you see he also took the relations down. So we have now a number of correct answered questions for every participant. So now let's first see how many participants we have with 0, 1, 2 or 3 correct answers. So we create a frequency table. We go on click anywhere in the table, go on insert, pivot table, new worksheet, and here we want to have a frequency table for the correct answered questions. So I put the same variable, correct answered questions, into the rows and into the values. Now I have the sum here. I need to have the number or the count. Therefore I need my value field settings. Yeah, get your value field settings when you click here on this little triangle. And now we have the number. So you see, if you also insert a diagram, insert diagram. Okay, so we insert the data. So now you see the heading of the diagram would be number of correct answers, and the explanation would be most students in brackets 42, that is the first bar, could answer 0 questions correctly. Maybe it makes sense here also to explain the axis. So here if you click on this plus, then here you can take the titles for the axis, and here we want to have that is the number of students. And here you want to have the self-assessment of general knowledge. So the explanation here would be that no, that's wrong. This is not the self-assessment, this is the number of correct answers. So the explanation would be, you would relate to the highest and the lowest number, for example. So you can say most students in brackets 42 didn't get any answer correct, and only 3 students had all questions correct. Yeah, 3 correct answers. Now we want also to see what is the relationship to the self-assessment of general knowledge. Did those who rated their general knowledge very high could they also answer a lot of questions correctly, or did they answer only few questions correctly? That would be what the Dunning-Kruger effect states. So let's get back into our first survey. First I have to make this diagram a little bit smaller so that I have some space here. So we get back into the first survey, click into the survey, insert a new pivot table, and I want to have it now in an already existing worksheet. I have to click in the worksheet. Here I want to have my new table. Now I want to have a cross table of these two variables, general knowledge and also correct answered questions. And I put correct answered questions also into the values. So, and I also insert a diagram. Yeah, but I also have to change from sum to number, to count. I will get nonsense here if I don't do that. So that is a typical mistake that I very often forget, and I also know from students that they sometimes forget to do that. Okay, so here we have the diagram, so let's interpret the diagram. I insert the data. And I have to do it for every bar. Okay, so first what we see here, 3 correct answered questions are the yellow bar. So we only have one yellow bar. These were those who estimated their general knowledge with 3. Yeah, so let's also give some information about the axis again. So we click on this plus, Excel titles, and then we have here we write self-assessment general knowledge. And here on the y-axis, this would be the number of students. So that you can say 19 students rated their self-knowledge with 2, and that is a blue bar, and they didn't get any question correctly, because the blue bar is for those who did get no questions correctly. One didn't rate his general knowledge. He also didn't get any question correctly. Interesting here for the explanation are those who rated their general knowledge with 4. And here you can see that none of them could answer all 3 questions correctly. That is typical for experts. Experts usually don't rate their knowledge at 100% because they know what they don't know. Dunning-Krugers don't know what they don't know. So you have 4 people here who didn't get any question correctly, and 5 people who only did get 1 question correctly. So that would be our Dunning-Krugers, because they overestimated their knowledge. And we also take as Dunning-Kruger here this blue bar, because these rated their general knowledge with 3, so relatively high, but they couldn't answer any question correctly. So these would be our Dunning-Kruger. So the explanation could, for example, be of those who rated their general knowledge with 4. We have 4 persons who couldn't answer any questions correctly, and 5 who could only answer 1 question correctly. That would be a brief explanation for this diagram. Now let's calculate a Dunning-Kruger factor, and then we want, for every person, we want to say if he's a Dunning-Kruger case or not. So we go back into our first survey, and here we calculate the Dunning-Kruger factor. I call it DKF for Dunning-Kruger factor. We calculate it as a difference between the self-assessment in general knowledge. So equals, because we have to calculate now, then I go to general knowledge minus the number of correct answered questions. That is here. Minus 0 in this case, because this person didn't answer any question correctly. So enter. So he has a Dunning-Kruger factor of 7. That cannot be. Oh yeah, again, I'm in the wrong line here. I'm line 103, and I need to start from the beginning. So I need to start from the top of the table. That is here. So here equals general knowledge minus correct answered questions. Minus correct answered questions. So this person has a Dunning-Kruger factor of 1. He rated his general knowledge with 3 and could answer 2 questions correctly. So this is an expert, obviously. He knows what he don't know. He's not a Dunning-Kruger. Dunning-Krugers are those who rated with 4 and couldn't answer any questions correctly. Then they would get a value of 4, or could answer just 1 question correctly. Then they will get a value of 3. Yeah, because 4 general knowledge minus 1 correctly answered questions equals 3. Same thing for those who rated their general knowledge with 3 and answered no questions correctly. That would be 3 minus 0, also would get a 3. So the 3s and the 4s will be our Dunning-Krugers. So let's fill in. Here we again have something that cannot be because we have no such a high value. Okay, I was in the wrong column. I was in the column rate your knowledge in statistics. Yeah, that is D, and I wanted to have general knowledge when you try to be fast. So general knowledge was E, so I just replace the D with the E, then it should be correct. Again, autofill in function. Now I should have only numbers. The highest number should be 4. And 4 and 3 are our Dunning-Krugers. So let's have a look at the frequency table again. Okay, so Dunning-Kruger, Dunning-Kruger, we want to have the number, not the sum. And we insert a diagram. So here you see, so those with a 4 or a 3 are our Dunning-Kruger cases. So we have 27 Dunning-Kruger cases. Yeah. So the explanation here would be that you write beneath the diagram would be that those with the 4 are those who rated their general knowledge with 4 and couldn't answer any question correct. Those with the 3 are those who rated their general knowledge with 3 and couldn't answer any question correct, or those who rated their general knowledge with 4 and could answer only 1 question correct. So these are the Dunning-Krugers. Yeah, so we have 27 Dunning-Krugers in our data set. Now you can examine more hypotheses. For example, it would be an interesting question if there are differences in the Dunning-Kruger effect according to the classes. So our null hypothesis would be there are no differences in the Dunning-Kruger effect or in the Dunning-Kruger factor, and our alternative hypothesis would be we have significant differences in the Dunning-Kruger factor. I have no clue in which direction that goes, if the management students have a higher Dunning-Kruger factor, but we will see. So we click into our table again, enter a new pivot table, and now I want to have the same worksheet. Yeah, here I want to have it here. So, and here I compare the averages of the classes, or all the classes, and their averages in Dunning-Kruger factor. Here I need to calculate the averages. And now you see, let's also insert the diagram. Okay, I only want to have 2 places after the comma here. Don't want to present this thing, so double click on this button, and then here we have number. There you can change from standard to number, and that has automatically only 2 places after the comma. So let's have a look at the result. So obviously the highest Dunning-Kruger factor we have here with social work 2. The lowest Dunning-Kruger factor we have international students. Alba is somewhere in the middle with 1.3. Okay, now you can also, some tasks, maybe you pause the video here and you compare if working students have a lower Dunning-Kruger factor than not working students. You can also compare if people who drink alcohol very often have a higher Dunning-Kruger factor, or if women have or men have a higher Dunning-Kruger factor. Yeah? So just make a pause and evaluate some hypotheses by comparing the means. Okay, now we create a new variable, last step for today, and we want to have not only the Dunning-Kruger factor, but we want to create a Dunning-Kruger factor 2, and that should just show us which persons are Dunning-Krugers and which are not. And for to get that, we need to sort again our table, and then here we have the lowest numbers. So here we take n for let's say for normal people, yeah, and I take the autofill in function, then I scroll down, and starting with the 3s, here we have our Dunning-Krugers. So here we enter DK for Dunning-Kruger. So these are our cases of Dunning-Kruger, the students who overestimated their knowledge. And now we can again evaluate hypotheses. For example, the hypothesis, do we have more Dunning-Krugers among women or more among men? And again, notice the difference. Here the first Dunning-Kruger factor is interval scaled. Here you have a scale and you can calculate the average. The second Dunning-Kruger factor is just Dunning-Kruger or normal person, so it's just nominal scale. You cannot create an average, so you have to use a cross table if you want to evaluate the question if women or men are more often Dunning-Kruger. So let's do that. We go and insert pivot table in the same worksheet again, because I want to have it all in the same worksheet here. Say OK, and now I take gender into the rows. I take the second Dunning-Kruger factor into the columns because it is nominal scaled, and also into the values. And now it makes sense to have the percentage here, percentage in the row, that is here, and percentage in the row. Okay, and then we also insert a diagram for this cross table. Insert the values, so now you see here diverse people. I think we only have 3 diverse people in our data set, so that is absolutely not generalizable. But here you see that females, you have 24%, blue is the Dunning-Krugers, 24% of females overestimated their knowledge and 23% of males. So that is a very small difference. I think it's not significant. Yeah, how to calculate significance we will see in the next weeks, but it's not significant, I think. So basically we cannot refute the null hypothesis that there is no difference between males and females. Okay, you can now also take the second Dunning-Kruger factor and create a cross table with second Dunning-Kruger factor and the classes, or the working and not working students, or other variables. Yeah, so just try it to get used to these typical procedures, typical basic procedures that you absolutely need to apply in your statistic project. Thank you for your attention. Hope you learned something, and see you next week.